Thank you. I welcome to all of you to our second colloquium of arts meets science and science meets arts, which will go on in the winter term and will continue in the spring term. It's in an experimental stage, I could say, this idea we had with Violeta, the Dean of Arts. And the first meeting that happened, I think, 8 days ago, it went very well. So we are enthusiastic, and we continue with the second one today with two excellent speakers, one from the class of arts and one from the class of natural sciences. Before I give the floor to my colleague, Violeta, I would like to, I can see that we have two distinguished members of our presidential office, the president of our academy, Professor Mainzer, and the vice presidents, Professor Harris. So I could like to give the floor to Professor Mainzer first, and then to Professor Harris to say a few words about this meeting.
Very wonderful idea.
Unmute, please. Unmute, please.
Unmute. You have to put unmute. Yeah.
Fine.
Now I'm a little bit surprised because I thought I'm only a participant today. I introduced last week, and perhaps you took part in this event, and at that occasion I remind you of the long tradition of arts and science especially in Europe since Greek antiquity until today. And in the beginning there was actually a unity of arts and science. Perhaps in the second talk we will hear a little more details about that with the celestial harmony of the Pythagoras tradition. And anyway, nowadays it is a little bit tricky concerning the relation of arts and science. And I'm eager to learn more about that, especially in modern time, from the part of scientists, because I'm from the part of arts, because I'm a scientist, and so it will be, I think, very interesting for me to learn more about the relation of science and arts for the future strategy of our academy. Thank you.
And Professor Vice President, Professor Birgit Harris from the class of humanities. So
yes,
we need also your class.
Can you hear me, Ioannis?
Yes, I can hear you.
Others? Yeah, you can hear me. As Klaus Mainzer, as president, I just here to listen to your interesting referates, and I'm in class 1. I'm responsible for literary studies, and so I'm very interested to hear both of your papers. And I think because I don't know these two people, and so I'm very engaged to listen. Thank you.
Thank you, both of you. Violeta, the floor is yours.
Thank you very much, Ioannis, for these wonderful ideas. So I must tell you that I'm very happy and honored that I succeeded in receiving contact with our member of class 3, Robert Morgan. You cannot imagine how often I tried to persuade him to come to us here. For the first time he said no, and then the next time he said so again no, and finally I received a yes. So I would like to present Robert Morgan. Is an international acclaimed critic, writer, curator, poet, and painter, and he lives in New York City. Now he is there and he will contact us from New York City. He holds an advanced degree in fine arts and a PhD in contemporary art history. He's professor emeritus at the Rochester Institute of Technology and adjunct professor of fine arts at Pratt Institute in Brooklyn, New York. Morgan is the author of several wonderful books and among others, Art into Ideas is his main idea, his leitmotif, essays on conceptual art, the end of the art world, the artist and globalization. In 1999, he received the first Archival Award for International Art Criticism in Salamanca in Spain. And in 2011, was inducted into our Academy of Science and Art in Salzburg. Dr. Morgan currently writes art criticism for the Brooklyn Rail in New York City. His archive of documents on conceptual art is in the collection of the Hesburgh Libraries at Notre Dame University. And since the 70s, he has maintained his role as an abstract painter whose work was shown in a retrospective also exhibition at Proyectos Monclova in Mexico City. 2017. Please, Robert Morgan, you have now the word. Thank you very much for coming.
Thank you for that very generous introduction. I so much appreciate it. And I appreciate being with a European group of intellectuals. And this is my great honor. I'm going to talk about the role of the artist in criticism today. And let me just say that I'm not used to reading talks because I discovered a number of years ago that sometimes the more extemporaneous style is more communicative. But I'm going to read today and see how it goes. And hopefully it will make sense on some level. And later, I suspect we'll have some questions and so forth, and I look forward to that. Some years ago, I got involved in a conversation with another critic that suddenly turned from a modest discourse on contemporary aesthetics to works of art that were hot on the market. My colleague's concerns were specifically related to the work of a conceptually oriented artist known at the time for his somewhat distant, cynically detached paintings produced by first-rate craftsmen he had hired to work in his studio. The critic exclaimed, "I used to think he was a lesser artist, but now after the events of recent years, I've decided he is good." "Why good?" I retorted in amazement. The critic's response, "Because he captures the superficial aspect of things in our time." It occurred to me that this was a prescient yet misleading belief, that a work of art is good if it appears to reflect or echo the times. Even if the critical context surrounding the work suggests a lesser significance than what is really there, my perspective on the artist's work to which he referred suggested it was more related to cultural anthropology than to contemporary art. Given the absence of a formidable criterion by which to determine its credibility, I could easily understand how such works might be discussed in terms of the human condition, largely because the research involved in the social sciences is perhaps more neutral and thus more sympathetic in recognizing the tenets of a particular culture at a particular moment in the work's history. Much of the art being produced and being promoted, bartered, and sold on the market today is contemporary. It is in fact less about art than about the research that stands behind it. In many cases, this would include the social scientific ordering of objects that are projected within an already given, possibly obsolete cultural reference. Since the explosive rise of the market in contemporary art over a half-century ago, certain kinds of art have begun to function primarily in terms of their commodity value. In this case, under the rubric of being conceptual. These images objects, and events are fueled through a market-driven domain of stark advertising and promotion. In such an environment, criticism is hardly the issue. It simply doesn't matter. What matters is how the artist's work is driven. That is, how it is brought to the attention of the public through promotional techniques and not whether it carries historical significance. It is mediated rather than understood. This is true of much of the work represented in today's market, wherein the work is fundamentally based on trends that manage to escape critical attention, often in defense of the galleries and collectors that support them. Parallel to the production of trends in contemporary art, the personal aspect of art has been transformed through the manipulation of detached images in search of commercial appeal. Often these images are relatively mindless, yet capable of accelerating the market for trends into overdrive. Now that the market is in a hiatus, not necessarily a decline, perhaps it is best to reflect on what the market is trying to do next. It is merely a matter of mirroring what we already know by way of entertainment, fashion, and commercial media. Or will it become more superfluous relative to how we feel living in a world steadily approaching a lust for the artificial? If we choose the latter, art begins to take on a somewhat problematic role, focused on various forms of artifice and socio-political obsessions. From a more critical perspective, art becomes a mirror of another reality, whereby media on a larger scale inhabits a world devoid of art on a level that proves greater and more efficient than what art can offer us. The seduction of art is finally greater than what it signifies. What does it mean to live in the present? Not the real present, but a copy of the present, a kind of mediated present that is difficult to determine holistically. In the midst of this, how do we recover the emotional means whereby we feel the need to return to art? On a critical note, I would like to suggest that there are significant works of art that exist in the studios of artists whose work I have seen directly in various countries throughout the world. Artists who are, for whatever reason, disconnected from the existing market, removed from the artificial present. Put another way, they are artists in the real sense. They are artists that appear significant rather than reaching for a symptomatic order of what art is supposed to be at any given time. These artists are, of course, the exceptions. They are the ones who proceed from the modicum of truth and continue to move in the direction, whatever direction that might be. The distortion of this truth is equal to the desire to meander in a circular orbit, which some artists have done far too often and clearly not to their benefit. It appears that these artists have become symptomatic of their time rather than allowing themselves to become significant. In some cases, they have deliberately removed themselves from the temporal moment in which they live. Their moments of desperation could be real at the point where conformity takes over from where independence left off. This raises another question as to whether art, what appears symptomatic, will inevitably become significant, and vice versa. One might argue, for example, that while the conceptualist has more or less retained his symptomatic status throughout his career, his work has yet to appear significant. In this case, in the case of other artists whose early photographs are significant, quite significant early on, it appears that in recent years, her works have transformed into a self-endowed quandary of symptomania. It is curious that this tension between symptomania and significance has not been given more attention in recent years, especially in view of the post-pop phenomenon, now at least 5 decades in reverse of the present. Have the faster, smaller informational media that came into aesthetic prominence in those years somehow distracted us from seeing the cause and effect relationships so evident in the unseen magnitude of the present? There is little doubt that Marshall McLuhan was in touch with this line of intrigue, perhaps more than his followers. Even so, the comprehension of a division between these phenomena was critically weak in coming to terms with analyzing the difference between the qualitative and the quantitative dimensions of sublimation that high technology has given to art within the larger scope of our diligent and persistent global environment. Given that big money interests are behind artificial intelligence, as they proceed to embrace a polymorphic flow of hidden information concerning how we think and potentially how we feel, qualitative thinking in relation to art is disappearing into an endless chain of algorithms. These presumably precision tabloids are limited in their stark inability to weigh the importance of qualitative thought. Yet concurrently, without the means of a qualitative measure, algorithms are unable to function. In other words, the end of critical thought is the price we pay for the sustained use of algorithms in their futurist applications to art. So the question returns to the symptomatic phases of cultural anthropology that have taken over art criticism. Instead of qualitative thinking, we are exposed to scholarly research to prove the existence of art, which ultimately cannot be done. To put it simply, art is traditionally less about facts than feelings, the latter of which cannot be defined. As the French symbolist, poet Mallarmé tried to make clear, art has no definition, only suggestion. And as Marcel Duchamp revealed in his Ready-Mades, they may or may not exist as art. Whether they exist as objects or as art is a matter of choice, but both cannot exist at the same time. We might say their certainty as art is none other than the exhilaration of discovery, whereupon we see and we feel what unknown artists have done, which at times appears remarkable. Now, if I can just make a few remarks on what I've just said. The quantitative aspect of art is not real. In order for qualitative thinking to become real through art, we have to think in relation to feeling. Thought in relation to feeling is beginning to disappear from art, particularly with the advent of conceptualism. And I might say at this juncture that I have written 3 books on conceptual art, and my dissertation was on conceptual art. But I am extremely skeptical of conceptual art, the way it is marketed, as I've tried to point out in my early remarks. That the context by which conceptual art is going to succeed will be the context of feeling. This is an important point to keep in mind or to grasp, however one wants to understand how to grasp it. We have to move from what we presume to be art to what is art. Art has a history, like other aspects of the humanities. That history needs attention. And of course, attention is, I suppose, extended through our cultural presence. The cultural presence cannot escape art, and art cannot escape the presence of culture. However, whenever I hear the term of global art, I am forced to think immediately of money and investment. I'm not thinking of what art contributes to me through the culture by which it has come to exist. I would insist on the continuation of art and culture as absolutely symptomatic of one another. This is essential. When we leave culture out of art, we're only looking at investment. And this is not the direction that we need to go. We need to understand that there is a strong cultural basis in every strong work of art, that they are relying on one another. As our world becomes more and more complex in terms of information, the presence of art is something that we need to restore. We need to restore the fact that feeling is important in relation to knowledge. How do you feel knowledge? You feel it through art. Art is the finalization of how we come to know ourselves and how we come to know one another, and how that enters into our world culture. We have to share that culture with one another, and in that way, come to respect art again as something that is essential and important to us. I don't think I can hear. What do I do about that?
Oh, now okay. You hear me?
Yes, I can, yes.
Thank you very much. I was feeling like a sentence, what you said. And it's so important that you spoke about feeling, because without feeling, how can you come to the essence of our souls? And in the essence of our souls is also the source of our art. I would like to ask you first, but I would say that the question will come after the second colloquium. That's why thank you first very much. Please remain with us. And now I would like to ask Ioannis. Ioannis, are you there to present the next lecture? Please remain with us, because after...
Okay, here I am. I was muted. Thank you, Professor Morgan. You can stay, because at the end we have some questions, for both of you and Professor Burkert. Now let us move to the next speaker from the side of science, ANDREAS Burkert, the Pythagorean music of celestial spheres and modern astrophysics. A few words for our member. ANDREAS is a professor at the Ludwig Maximilian University in Munich, Department of Physics, University Observatory, and member of our class. ANDREAS Burkert holds the chair for computational astrophysics and at the University of Munich since 2003. He got his doctoral degree from University of Munich and then went to the further Linnean Fellowship to the University of Illinois Urbana and to the University of California, Santa Cruz. In 1991, he joined the Max Planck Institute for Astrophysics in Garching as a staff member, and in 1995 accepted an offer from the Max Planck Institute for Astronomy in Heidelberg to build a new theory group. ANDREAS' research focuses on the dynamical processes in the universe, including the structure and formation of dark matter, halos. Actually, halos probably it's a term that is not familiar to you. Well, it's a basic cosmological structure and it's a hypothetical region in the universe, and something which has been decoupled from the cosmic expansion, and according to the theory, it contains matter. And also his research focuses on the formation and evolution of galaxies, the structure of the multi-phase turbulent interstellar medium, and the formation of stars and stellar clusters. Many physical processes in the universe are highly non-linear and coupled in a complex way. A deep understanding of the dynamical universe often requires detailed numerical simulations coupled with sophisticated data analysis and visualization. Professor BURKERT and his team develops new software and data visualization tools. Dear Andreas, the floor is yours.
Thank you very much. I don't know where you got all this information about me.
Thanks to internet.
Oh, I see. Thanks. Oh, I didn't know there's so much about me on the internet. Yeah, so let me see. So I would like to share the screen. Let me see which one. I got this one here. So I hope you can see it. So wait a minute. Okay, that's what I want to show. And I brought a couple of pictures because I personally think that pictures, especially when you talk about the universe, tells more than any words. And just visually looking at this, I think it's similar to art. You get the feeling, what it means for you. And I completely agree with the speaker, the last speaker. It's all about feeling. If you want to understand our role in the universe, then it's a personal feeling you need to gather, because it's a human enterprise, basically, which we talk about. So let me now see. I would like to start with a quote of Richard Feynman, who has been one of the most famous physicists, an American physicist, who lived in the US. And Richard was once asked by an artist why he's taking apart all these beautiful things one can see, like a rose. When you take the rose apart, you destroy its beauty. So is this the right way to do it? And Richard answered, he can, of course, feel the beauty and smell the rose like anyone else, but there is a deeper beauty which becomes only visible if you understand how the rose came into the universe. And that's why you need to take it apart. And this beauty is more abstract, but it is deeper than anything else. Now, I've been studying the universe for many, many years. And it changed my attitude, my life, how I think about everything. And one of my goals is not to take this till I die, but to distribute it, to explain to others why it's so fascinating and why it might be of some importance. And that's why I'm so happy that you allow me to talk a little bit about this. And I try out now different ways to communicate it. And I learned that actually art and music help a lot to communicate the sometimes dry science of the universe. So I actually work together with some musicians, and I talk a little bit about the universe, and then they play some music so that people can digest and let it sink down. And then I continue a little bit with pictures. And that is really rewarding. A talk of 45 minutes or so is just overcrowding, overdoing it. But this combination works very well. And I have Ugo Dossi, a great artist with whom I'm working on basically explaining some concepts, like here the supernova explosion, a big star exploding and distributing the pieces and the stardust, which we are made out of into the universe and so on. So, and I hope through connections here with the academy, there might be more coming up where I can test and try out different concepts to bring science together with art and music in order to explain the beauty and relevance of the universe. So I have been asked to talk about Pythagoras, so I start with Pythagoras, but then I move into modern astronomy, which just extends on Pythagoras. So at that time, 500 before Christ, so to say, there was already something known about the universe. The Earth was in the middle, and there were the planets and the sun and the moon orbiting around the Earth. And in this geocentric world model, the people were connected to everything. You know, God wasn't removed from the Earth. We were part of this. Actually, if you go to the Egyptian mythology, then sometimes you could be God yourself. And this harmony of the spheres, because everything was moving on circles, was part of the life of human beings. And the people thought, okay, when something moves around, you can hear it. So they thought the planets hum based on their orbital velocity. So there is different humming for each of these planets. And so that leads to a certain sound, which should fill the whole universe, but it's imperceptible to human ear. And they were wondering about this. Why can't they hear anything? And then they thought, okay, well, it's very simple. If you hear one sound all the time, always the same sound, then at some point you cannot hear it anymore. Your brain shuts it off. So actually this harmonics, this celestial sound is actually what we call silence. And the people thought it enhances the quality of life. And the quality of life is reflected in this tenor of the celestial sound. I like this. It's a really beautiful view, which kind of brings together the universe and us. But it has a problem. It's not music, because it's constant. The idea was this moving around is forever. The planets always move the same velocity. So it's just one everlasting chord. And this is actually a little boring. And I will want to show you that actually the universe is much more fascinating, and there's a whole orchestra and a lot of music, but it's always an ever-changing. And that is, I would say, the modern view. Now, as you all know, we're living in a heliocentric world model where the sun is in the very middle. Was set up by Copernicus, and then Kepler even showed that these are not circles, but more ellipses, more general. But even Kepler thought there must be this kind of eternal sound. And but Kepler said the celestial hum can only be heard by our soul. So the ears, they are not made for this. And I like this too, because that's actually what it does. When I talk about the universe, when I give it a talk in front of people, then I can sometimes see that it touches their soul. And this touches then also my soul. So in that sense, there is some communication in the right direction. Now, let me move to the modern solar system. And here it is. This is our solar system. And it has the 4 planets, inner planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And this is already a lot of harmony and symmetry. Harmony in the sense that all these 8 planets orbit in the same direction around the central sun. And they live in one plane. It's like a plate, if you so want, moving in this kind of harmonic way on a circular orbit around the sun. And you see there's much more in the solar system. The planets are actually the most boring part of everything. Yet there's even more harmony and symmetry when you look at them. Let me focus on one planet, which is the giant Jupiter, the biggest planet in our solar system. Actually, if an extraterrestrial person would like to find life in the solar system, this person would probably only see Jupiter and might wonder, why isn't there any life on Jupiter? It's very hard to see the little Earth, which you see over there. This Earth is smaller than one giant storm, which you see here on Jupiter. Now, Jupiter has its own harmony because it has moons. and many of them had more than 50 moons, but I just want to talk about the Galilean moons, which Galileo Galilei first discovered. And here you see them. You can beautifully see it in any small telescope. And I have my telescope out when we get some friends over, and they always are fascinated when they see these 4 moons. Because what you can see is they are again in one plane. They move exactly like a little overtone solar system around Jupiter. And that actually convinced Galilei that we are not with the Earth in the center of the universe, because then why don't these moves move around us? They move around Jupiter. They don't care about the Earth. And there's even more interesting when you look at this kind of symmetry which you see around Jupiter. Here are the 4 moons: Io, Europa, Ganymede, and Callisto. And what you see is they are all beautiful, and none of them looks the same. They don't look like our moon. This Callisto, this is an ice moon made out of ice. This is a volcanic moon. There are volcanoes on it. Europa and Ganymede have very special structure. Each of these moons would be worth a talk itself, and has lots of fascinating physics and characteristics, unseen anywhere else, unique. It tells you moons are not at all boring. They are so much more fascinating themselves. But there's even more to this. Here is the orbital period. That means how long it takes those moons to move once around Jupiter. And the first surprising effect is that it doesn't take them a month. When Jupiter is much bigger, you might think much larger. It takes them just 2 days to move around, which means you can see them moving, across the sky in 1 day. And yeah, there's something else which is fascinating. This is 1.8 days. Europa is 3.6 days. It's twice this. And Ganymede is 7.15 days. It's twice this. And Callisto is 16.7, is twice this. There is a symmetry in it. Always twice the other moon is the orbital period, a very beautiful overtone, which you should add to the music of the spheres if you want. And unfortunately, I haven't seen someone doing some music, including the moons of the solar system. It would be very interesting to understand what kind of sound that would lead to and what one can do with this. There is not only harmony in the solar system, there's chaos too. And chaos and harmony go together. And I want to demonstrate this with the asteroid belt. So here's Sun, then Mercury, Venus, Earth, and Mars. And here's our Jupiter. But in between Mars and Jupiter, there is place for another planet. But the planet never formed. Only the bits and pieces, which we call asteroids, that could have formed the planet are there. So we know actually planets didn't live forever. They were part of a small object that later on collided and grew to planets. And here in this region, this does not yet happen. We still see kind of the parts out of which a planet should have formed but didn't. You see something very interesting. You see that Jupiter has captured some of these asteroids, and the Trojans are, and the Greek, basically the Trojans are moving, kind of chasing the Greeks and vice versa. And they are in a very nice geometrical shape. This is always 60 degrees, it must be so, and they just follow Jupiter moving around. But Jupiter is not only capturing some of these asteroids, it's also deflecting asteroids from their orbit. And these asteroids go crazy. They generate chaos and they move through the inner solar system. And they cross the Earth orbit twice a year. And they can become dangerous. In fact, you can work out, if you look at the radial distribution of these asteroids, I mean, how distant they are, how many you have at a certain distance, then you see here how many asteroids you have at this distance, this one. And then this, you see, this looks almost like Monument Valley. There are certain places at certain distances from the sun where all the asteroids have been removed. And there are other places where the erosion is less much. And this is all part of the chaos of Jupiter interacting with these asteroids. And the important part is that these asteroids can become quite dangerous to us. And you know, every few million years, one of these kilometer-sized objects hits Earth, and for sure there will be another such event happening. It's overdue actually, and the dinosaurs were too dumb to figure something out and to understand it, but we shouldn't be that dumb, and we should do something against it, and we don't yet do anything. So this is another problem we have. But it tells you there's not only harmony, there's also chaos. And there's something even more important. Actually, when the solar system formed, it didn't know about harmony. Now it's around for 4.5 billion years. So it has learned to live in a kind of structure which is stable. But when it formed, it wasn't stable. It was messy. There was chaos. And you can see this here in this simulation. This is how the solar system is now. And here's Uranus and Neptune. But when the solar system formed, we know that actually Neptune, who is the outermost massive planet, was farther in. It was here. And Uranus, which is farther in, was out there. And let me see whether I can run this. I can't run it anymore. I'm sorry. I thought I can run it. I cannot run it. But what happened then later on, the solar system found out it's not stable. So it redistributed everything. And now Uranus is outside of Neptune. All the orbits of the planets changed slightly, and it could have fallen apart, but fortunately it did not fall apart. And then at the end, out of chaos, you got harmony. So this tells you, if you want to hear this kind of music, there should be also a chaotic part of it, which leads to harmony at the end. But if this is true, it means that nothing is there forever. There is evolution. And I consider an evolution something that changes over time, much more like music than a tone that is always there forever, a hum that exists forever. That's to some sense a little, it may be, I would say, relaxing, but at some sense boring. But our universe is not boring, so it is evolving all the time. Now, this was the solar system in the outer parts, but in the center there's something fascinating. Again, there's a star. It's our personal star, and it's called the sun. And here you see the sun. The sun is really big. You know, here's Jupiter, and the Earth you cannot distinguish anymore. The sun is a gigantic star, and it is made out of two elements, which are the basics of everything, hydrogen and helium. This also, Jupiter is made out of hydrogen and helium. And our sun is really special because it takes this hydrogen and converts it into helium in the innermost furnace, which has a temperature of 15 million degrees. So it's called fusion. And by this, the energy, the sun, it burns. And it's beautiful because on the surface of the sun, it has a temperature of 6,400 degrees. And this is just the right temperature such that at the distance of the Earth, we have liquid water. We call it the habitable zone. So somehow it was set up that way, and it's beautiful. And you can, of course, say, well, okay, well, if the habitable zone would be somewhere else, if the temperature would have been very different, then okay, well, then life would not have formed on Earth, but there are other planets out there, and wherever there's a planet in the habitable zone, it would then have happened there. But if you say this, then you actually say that life can form anywhere in the universe. Anywhere where a planet can sit in a habitable zone, there is life possible. And that means, as we know, there are many planets in the habitable zones, that there must be life everywhere in the universe, not only here. Now, our sun has something else, which is really, really beautiful. it's absolutely reliable. Because if this temperature would change, let's say by a few hundred degrees, let's say 6,000 or 7,000, we would move out of the habitable zone and life on Earth would die. But for the last 4.5 billion years, the sun has always had this temperature and it did not change at all. Amazingly stable furnace. And you should really be proud of our sun that is doing this. But the problem is, of course, it cannot go on forever. And that is another aspect of modern astronomy. Nothing is there forever. Everything is part of a bigger cycle of coming and going. And the same is true for the sun. The sun formed 4.5 billion years ago. We are now at half time. And in another 3 billion years, it will realize it runs out of fuel because the hydrogen is exhausted in the very center. And then it will become very large. It will form what we call a red giant, a beautifully large object, but it will basically engulf the inner planets. It will burn the atmospheres and the surfaces of the outer planets, and life will die on Earth. And then the sun will blow away the outer parts. And what is left behind is a little white, small object, which we call a white dwarf. And so we know we formed 4.5 billion years ago, and we will die in another 4.5 billion years. So this humming of our solar system will end. It's only there for a finite amount of time. Now, these dying stars are beautiful. And I'm not even sure what it means, beauty, in this context, but I simply say this is beautiful. This is the Cat's Eye Nebula. And it's one of these exploding stars. This star is 4.5 billion years older than our sun. That's why it's exploding now. And here you see the white dwarf. And this is the atmosphere that is blown away. And just looking at this, this is an observation. It's not a painting. I just almost think of that nature is doing art. I know art is a human business, but it comes close to what I consider art. And maybe we can talk about this. At least I consider this absolutely beautiful. And in fact, each of the stars, when they explode, look differently. Here you see the Eskimo Nebula, another dying star. Each star has its own characteristic when it dies. None of them looks the same. And I'm really looking forward to our sun when it explodes, what it will look like. Now, our sun is not alone. We are not alone in the universe. There's more. There are more suns. And when you look out at night, you see all these beautiful dots, which are all stars like our own. And you see this bright line here crossing the sky, which we call the Milky Way. And the people have been wondering what this Milky Way actually is. In modern life, we can have the telescopes and we can look at that. And you see then that this kind of bright patch here is actually made of lots of dots. And each dot is a star like our sun. And you can actually count how many of dots you have. This is why you have your students. And at the end, you come up with a big number. In the Milky Way, there are 100 billion suns. Each seems to be surrounded by a solar system. So you see how much music there is in the Milky Way, because each solar system, again, looks differently. And the Milky Way looks like a kind of strip on the sky or a band on the sky because it's again a disk. It's like the solar system, but a much bigger disk, 100,000 light years in a diameter. Here you see the disk from the side, here you see the disk from above. Here you see another galaxy where you can clearly see it's indeed a disk, and here from above. And we don't sit in the center of the disk, which we naively might believe. You know, when you study the universe, you become immediately quite humble, and it's really good so, because it's so relaxing. And but we live with our little star at the edges of our Milky Way. And so when you look along the disk, then of course you see many stars in projection. When you look perpendicular, you see a few, and that's why the Milky Way appears like a band on the sky. So we have 100 billion stars doing a big orchestra in this kind of universe. And around each of these stars, we see planets. And here you see a couple of planets that have been discovered. In the middle is the star, and around them is a planetary system. And each of these planetary systems look differently. You see this kind of wobbling, everything going around. And you might wonder, why is the universe generating all of this if life would have formed just on Earth? What a waste of structure and all of this. So I think life must exist everywhere. And we are just one part of life, which is actually good to know, because that means there's nothing guaranteed that we will survive. Simply because, you know, the universe doesn't care so much about us surviving, if you want so, because there's so much other life. Maybe we are not even the best life anyway for the universe. Now, let's move into the galaxy a little bit. And I show you this movie. This is Orion, a beautiful constellation. And we move out into the universe and we see all these stars moving by, but we see other things. We see big gas clouds. You see this gas cloud here. In this gigantic cloud of gas, new stars are forming. So we know every year in the Milky Way, a new star is forming with a new planetary system. But we also see stars exploding. Here's a Crab Nebula, an explosion of a star. And so we know every year somewhere a star is exploding. So every year a star forms, every year a star is exploding in the solar system. So you see there's an equilibrium. And now we fly out of this gigantic disk of stars and gas and star formation and star death into intergalactic space. And what you now see actually is a lot more. All of these systems you now see are not stars, they are actually galaxies. Each of these points is a galaxy with 100 billion stars. There's a gigantic number of galaxies out there, and all of these galaxies do the same as we do. They form stars, stars explode, and probably planetary systems form all over the place. So even if there's a kind of a concert in our Milky Way, all of these galaxies have their own concert and do similar things. So this is a big galaxy cluster. In the center, there sits a galaxy like our Milky Way. It's just 10 times more, 10 times bigger. And we fly into the very center, which has a gigantic black hole, but I can't talk about that. Here you see a galaxy cluster. And you count again how many galaxies you have, like the Milky Way. And it's again kind of mind-boggling. Just in the visible part of the universe where we can easily count, we find 100 billion galaxies, each with 100 billion stars and probably planetary systems. So even if life could form only once on one of these planetary, once in a galaxy, it would just be life all over the place. Now, this is part of modern astronomy, and it shows you the richness of the universe. But there's more. And this more comes from this fact. Light takes time to travel, 300,000 kilometers a second. And this means what we see is not what is there, but what was there when light was making its way towards us. We always look into our own past. You never see the things how they are, but how they were. When light started, you also don't see me as old as I'm really, but a little younger. And when we look out into the universe, we look into our own past and see the universe evolving. For example, this galaxy cluster is at a distance of 3 billion years. We see the universe as it was 3 billion years ago. How these galaxies look like nowadays, we don't know. We'll see this in 3 billion years from now. Might be completely different. And the question is, how far into the past can I look? If I take a little piece here and just simply collect photons again. What do I see if I look deep and deeper in the universe? And this is an image which the Hubble Space Telescope took. It was really a very expensive image. It was 1 million seconds of integration time. A second cost $10. So you know this is one of the most expensive images ever taken of the universe, $10 million, but it was worth it because it shows us the universe 13 billion years ago. We see the edge of the visible universe, and these objects were there 13 billion years ago. It's a distance of 13 billion light years. And what we realize is that these are not the galaxies we see nowadays. We suddenly don't see big galaxies. We do not see many stars. We see lots of gas, but nothing has yet formed. We see the universe was young. And if the universe is younger in the past, and if there's evolution in the universe, then there must be a beginning. Because if the universe would exist forever, all evolution would have already ended. But there must be a beginning. So what was there at the beginning? And for that, people, astronomers, looked at even a smaller patch and integrated even more and tried to find something in there. And guess what? They didn't find anything. If you go even further into the distance or in the earlier universe, there was no light because there were no stars. It was, we call it the dark ages of the universe. But there's something in this region, something which is directly connected to the Big Bang, and we call it the microwave background. It's microwave radiation, which you basically also get in your microwave, which is the direct echo of the beginning. So when our universe formed 13.8 billion years ago, it was a very small region, maybe a dot, filled with an enormous amount of energy. Energy is light. And then the universe expanded, and this light cannot escape out of the universe. And so it still comes towards us from these early phases, and we can see it. And this is actually really what I would call the music of the universe. Because you know, we cannot hear anything in the universe. You know, this is vacuum. So what we call music is actually light. And this is the orchestra out of which everything formed. It's hidden in this structured light, which we see from the Big Bang itself. And so we know there was a time when the universe began. And it's just fascinating to think about why. And I have no answer, and I'm probably need to talk to philosophers to figure this out, some other people, but this is beyond physics, I would say. Understanding why something is there and not nothing is something else. But it's very beautiful to watch it, and you can actually watch it. If you find one of these old TVs, maybe you have some of these, with an antenna, then when you turn the TV on, you see all this kind of dots here, you know, all over the place. And these dots are light from the Big Bang. Light travels, hits the antenna, and generates these dots on the screen. So I suggest take a good glass of wine, sit in front of your dots of the of this TV and enjoy the Big Bang, because it's really worth it. Now, in the Big Bang, and I get to my end very quickly now, hydrogen and helium formed, the origin of matter. That was anything, everything. So if you really want to find something old, don't take a stone, which is maybe 4 billion years old. Take a hydrogen balloon. The hydrogen in this balloon is 13.8 billion years old. Can't be anything older. Just do it and think about it. This, what you see, formed in the Big Bang itself. And that's why the sun and Jupiter, the big things in the universe, are all made out of hydrogen and helium. But there's a problem. You know, Earth and also life is made out of something different. So how did the universe generate these elements then? if they weren't there in the Big Bang. And lucky that they did. But how did they do it? Well, there are certain types of stars which are alchemists. I call them the alchemists of the cosmos. And they are big stars. Here you see one of them, ANDREAS, a gigantic star. Here's the sun in comparison. And these stars do something very interesting. They don't only take hydrogen, make helium out of this, but then they take the helium, make more heavy elements, carbon, oxygen, silicon, nitrogen, all these elements which we need to form planets like the Earth and life. So these elements are formed within the star. Now you cannot form life in the star. And so something else happens. Again, something harmonic, something rather special. These stars explode as supernovae. And for about a week, they are brighter than all the 100 billion stars of our Milky Way together, and then they die out. But in this kind of explosion, they throw out all of this beautiful stardust into interstellar space. And this is then the material out of which planets can form. And we see this directly when we look into the universe. Here's Orion. I showed you the Orion constellation, a wonderful constellation in the winter, which you should see here, the belt of the Orion shoulders, here the legs. And here is the Orion Nebula. The Orion Nebula is a star-forming region, a gigantic gas cloud inside which stars are currently forming. They are really young, they may be 1 million years old. But there's something else in this region. And the people discovered it recently. When you focus in this region, you begin to see something dark. It's a little disk surrounding a young star. And this is exactly the protoplanetary disk which we see in our solar system. It has the right size, and in this kind of disk region, the stardust coagulates and forms asteroids, and the asteroids merge together and form planets. So we see here directly a planetary system, a young new planetary system forming out of the stardust of previously exploding stars. And this isn't that a wonderful cycle of creation and destruction. And I always try to end with this image. This is not a painting. It's not created by Photoshop. It's a real observation, a real image of Saturn by the Cassini spacecraft. Now, what is special about this? It is a selfie of our Earth at a distance of 6 billion kilometers, and is called the pale blue dot. It's most fascinating you can think of, and you can reflect on that. And I actually want to convert this into art, but I need an artist to help me on that. So what do you see? Well, if you want to look at our spacecraft Earth from the real distance of the universe, you have a problem. There's the sun. The sun is so bright that you cannot see the Earth. So Cassini flew into the shadow of Saturn. The sun is on the other side, and you see a solar eclipse. You know, if you have seen a solar eclipse from the moon, you see this bright rim, and it's basically getting dark. And so that's what you basically see. And you see the rings of Saturn here. You don't see the rings because they're on the other side. And what you now begin to see is, first of all, let me see, wait a minute. Here. What you now begin to see, first of all, are the moons of Saturn. But there's one dot, which is something else. And this one dot is this here, a little blue marble, which is the Earth and our moon. And if you see this view of our spacecraft Earth, then you begin to wonder what we do with it. You begin to wonder that we are sitting in the same boat and that it's all depending on us to make it work, because the universe doesn't care, but we care. And we should actually preserve it, because we are those in the universe that begin to reflect on the universe. So there's something coming into the universe through us. We try to understand it. We try to make sense out of something. And that makes us rather special in the universe. So we better preserve it because I think it's worth it. And with this, I would like to stop. This is the ALMA telescopes in the Atacama Desert in Chile. You know, you see all these antennas watching and listening to the sounds of the universe and trying to figure out where we come from, where we go, and what is out there and what it all means for us. And with this, I would like to stop, and thanks for listening.
Bravissimo.
Thank you, Andreas. That was a fascinating presentation. I think the best probably status at this moment is the silence. But let us come back to on Earth, and this is a question time. If there is anyone who would like to let us start first with the first speaker, Robert Morgan. If there is anybody who would like to ask Robert Morgan, and then we move to the Andreas Burkert to follow an order somehow.
Yeah.
Prof, yes, Prof, Klaus Mainzer, Prof, the president.
Yeah, thank you to both speakers. And actually, I have a question to both speakers, namely concerning the objectivity and subjectivity of beauty. It was fascinating again to hear in the last talk from a modern cosmologist, astronomer, physicist about the beauty of even the modern view of the universe. And that is actually, and Andreas Burkert told us about that in the tradition of antiquity, coming up from Plato and Pythagoras, and then even Kepler. And but what about the status of beauty here? Is beauty something objective, connected with the mathematics of the old models of the universe, the modern models of the universe, or is it only a subjective taste of some scientists? That means humans. And you know, Plato and the antique tradition was confessed that beauty is something objective. It is closely connected with the mathematics of the universe. But if you consider modern scientists, of course, on the one side, there are people like, for example, here in Germany, in Munich, Werner Heisenberg. He was also fascinated by the symmetry and the beauty of the universe because the mathematics is so absolutely fascinating. But on the other side, there is another great physicist of the 20th century, and that was Weingart. And Weingart said, "Oh, the universe absolutely horrible. There is only death, and there are hostile race, and so there is no beauty." So it seems to be, and that is my question to both, what about beauty? Is it subjective, or is it objective in the traditional view?
Professor Morgan.
I hope he's there.
Oh, no, he is. Robert is back. Yeah.
Unmute, please.
Hold on one second.
Okay.
Can you all hear me?
Yes.
Yep.
Yes. Okay. I really love this question because it often comes up, not expressed in exactly the way you expressed it, but it's always very similar. And I would say this, that there is both there is both. There's the objective and the subjective. And when you're dealing with human beings, looking at works of art or having what John Dewey once called an aesthetic experience, which isn't precisely the same, because an aesthetic experience can occur without art, okay? It's a feeling that is a very human feeling. And from Dewey's point of view, this is necessary in terms of fulfillment of our everyday lives, okay? Now, on the other hand, I would say that there is an objective basis for beauty and for art. And I think this objective basis is something that is mathematical or geometric. I think that the distinction is an interesting one, but I feel that looking at art from a human point of view is always subjective, always subjective. But in fact, there is the objective consistency that I believe is built on the beauty that is offered through geometry, through mathematics. Now, that can happen in many forms. And if we go back to Masaccio, for example, during the Renaissance, you know, there is mathematics in that painting. There is geometry in that painting. And objectively, it is art. Objectively, it is art. But people that come to look at Masaccio, they have a subjective experience. So I think the difference has to do with the separation. It's not really a separation. In fact, it's intertwined totally. That there is the objective presence of the art itself, or perhaps the aesthetics, depending on what aspect of nature we're talking about in relation to aesthetics. But experientially, that is subjective, okay? And there's no way you can argue that it's not subjective, okay? It exists as objective, but it is experienced as subjective.
Yep. So I would completely agree, and very well done, Robert. I mean, now I know how to tell this to others because you did a great job on this. I think I agree with this. I sometimes wonder about what if you have an extraterrestrial person seeing something you see beautifully, find beautiful, would this person also think it's beautiful? And so because this has different experience, completely different. And I agree that there's this objective part where you have symmetry or you have interconnections which beautifully link together. And there's some feeling of you know, you feel good about this. And the subjective part, which is a matter of debate, because it also depends. My wife, when we go into a museum, well, she finds things beautiful, which I find boring, and I find things beautiful she finds boring. So in that sense, I think it's subjective, and everyone has his own feeling what it is.
Yeah, I would like to add on in this interesting little discussion. You know, I think we should take into account also that whatever we feel, inverted commas, because I heard many times, you know, this word we want to get expressed, but we found more convenient the word feeling. We feel the feeling. Something else we want to say, but we cannot find, you know, a term. So I think the relativity in this terminology of beautiful, ugly, good, bad, because we may expand to other terms that humans have devised. It depends also from our system of reference. I mean, we are living in the, as you saw before, in the solar system on certain scales of magnitude, sizes, colors. We have the five senses. We detect somehow. We have perceptibly, the colors, but they are not all in these colors. There are more colors. So in our small system of reference system, we develop what we say beauty or ugly. If we get away from this system and we move to another part of the universe, everything changes. Time has a relativity. Space changes, curves. So if we're living there, if we imagine we live in that corner of the universe, then whatever we say today here as subjectivity or objectivity changes.
Yes.
And take into account also the perpetuality in the ever-changing universe from ourselves, our nature, our cosmos, solar system, to the remote parts of the universe. I'm wondering if one would is wise to say what is beautiful, what is subjective or objective.
Can I add something? You can work out mathematically a lot of things in physics, but you haven't understood anything. That happens, unfortunately, with numerical simulations. I have a chair in computational astrophysics, but I am actually uneasy about calling it computational astrophysics, because if the computer works something out, I haven't understood anything. And I have to teach my students all the time, you need to feel it. You have to get a gut understanding so that even without the computer working it out, you intuitively understand what will happen. They sometimes wonder why I say this will not be working. And because I got this feeling over many, many years of experience. And that's why I do science, because science is not only to do mathematics. Science should tell us human beings a little about the universe, and we should feel it. That's why we do science. The universe does know what it is about. It doesn't have to be recreated, but it's for us, the science, to feel it, to understand it. For example, if you want to understand that the universe is expanding, but it's not expanding into anything. There's nothing around the universe, still it's expanding. You might be confused initially, but I am not confused anymore. I can understand it because I thought about it long enough and I have a feeling about it. And this feeling grows. And I think that's very important. So science without feelings, gut understanding is not good science.
Is it possible our grain of brain in the universal brain to ever reach, a point to comprehend universe, the universal brain?
Yeah. I think we can be proud that sitting on these little planets, we comprehend so much. I mean, this isn't that amazing. We even know about the Big Bang. We know 13.77 billion years ago it happened. So
theoretically and mathematically, but not theoretically and mathematically. It's a mathematical point. It's not a real, it's a hypothesis. This point.
Well, yeah.
And what before?
Yes, you never know. In some
that does
sense,
not stick,
you're right.
To this.
Yeah, the old story, you cannot really prove anything right. You can only prove things wrong, but you can never prove that you're right. I agree with you on that issue. But on the other hand, you get this, again, a feeling that things work out. The same in science, I can always go on with the same project forever because I could always be wrong. But I get a feeling I can go on to the next project because I think I got something roughly right. And then my colleagues tell me it's wrong anyway. But you know what I mean. It is
I know what you mean, but let us call that, let us define what is feeling. Is it the Socratian demonium?
Yeah.
Demon?
I would say,
it's another discussion.
I would say that the composition of the universe is objective. You know, I can't prove that, but it seems to be the case. Now, when you're talking about objectivity, there is time and there is space, and both are important. As a matter of fact, I would argue that both are connected. There is no time without space. There is no space without time. Now, this kind of objectivity is present, and people, human beings, come to this example, for example, what they see in a work of art or what they see in nature, and they have feelings, okay? Feelings are important. They're important because it's subjective and it defines who we are. We are defined by our feelings, not by mathematics, okay? On the other hand, we have to understand that the time and space around us and within us is real. We can't ignore that. And when we interact with one another, we have to understand that time and space are real, and that how we are feeling is absolutely connected with that reality.
Mm-hmm. There's something really fascinating I now realized with the Corona crisis. I do lots of Zoom meetings every day, whatever. You do the same, probably something like 5, 6, 7 hours a day, one Zoom meeting after the other. But I have seen that the students have forgotten how to creative talk to each other, because the Zoom meeting is artificial. And there's no excitement coming up anymore in these details. And we now recently I said, okay, forget about Corona, you're all vaccinated, we go and have a coffee together. We were there for 20 minutes. And there was an exchange of ideas. Suddenly, it was bursting. And all these brains somehow connected in a special way, and new ideas came up which never came up the last year. So there is a common feeling of what could be the right thing and what one could do. So this feeling, this interaction, this kind of, I don't even know how to explain it. The brain physicists can probably tell me how this works. But you see, it's an amazing thing that this interaction and this going beyond pure mathematics, which you can explain also in a Zoom meeting, is essential for human beings to make any progress, to talk to each other, to understand. You know what I mean.
I understand exactly what you mean. Right before I gave my talk, I was online with my students, my graduate students at Pratt Institute. And there is difficulty talking in the sense that you mean. I don't have an answer for that. I mean, I'm interested in this generation. And although I'm formally retired from full-time teaching, I continue to teach at least one class a semester to stay in touch, because I'm interested in, how they're thinking or how they want to think, or, what I can learn from them and what I can pass on to them. Okay. It's a very important part of how I see my reality at the current time. And it's a reality that I think is beautiful. I feel it and I want to be there.
Good.
Perhaps in the end, one can summarize that aesthetics or beauty has something to do with human feelings, and that human feelings are fundamental even for science, for research, because it is an important heuristics, it is important motivation for a scientist, and that was in antiquity, and that is today. Maybe that the subjective taste is changing in the history, but science is made by humans, and humans have feelings, and in that sense, they have aesthetics.
Well, you know, I would agree with everything you just said, but I would also add to that there is a scientific, there is a scientific objectivity, yes, but there also is an aesthetic objectivity. And as I was suggesting earlier, I think that it is important to recognize, for example, when you're looking at color, the color is performing in relation to a certain kind of objectivity, but the way we are feeling it is not exactly the same. We are taking it in on a very personal level that is hopefully rejuvenating our sensibilities to continue to explore these channels of involvement. We have to keep up with the times, as they say, but on the other hand, we cannot forget the past. This is very important in terms of science or art.
By the way, when I read for the first time the title of your talk, then I was reminded of Kant. And you remember Kant,
yes, of
he
course.
underlined that in both in science and in aesthetics, there is a kind of objectivity, but it is different. And so he made a difference between his critic of pure reason, that is science, and the critic of aesthetical judgment. That is, I think, the English title of his famous book, Kritik der ästhetischen Urteilskraft.
Yeah.
And there is objectivity, he said, he argued, but it is not the objectivity of, for example, the law of gravitation of Newton.
This is absolutely correct. And my respects to Kant. You know, I wasn't thinking of him directly, but obviously he is at the basis of aesthetic judgment. I mean, he wrote about that at a time when that whole idea was coming to the forefront of attention. It was, I think, you know, in the 18th century when the concept of the art museum begins to emerge. And that was, I think, a very important time. And we begin to think about art as something that has historical significance, but it has historical significance because we are in the present. And the present is also historical. And that continuum is something that is not very well understood in my country, but is, I think, very well understood in Europe.
Any other question?
I would like to ask Professor Morgan a question just in a entirely other perspective. As I understood you, you talked about the problems to get artificial intelligence, algorithm, and art together. So do you think that at least music and art has already more devoted to technology nowadays, so making music automatically or by a machine, and impedes a way to art in an essential sense that you meant?
Well, in fact, I am very skeptical about AI, artificial intelligence, in terms of its relationship to art. And I'll tell you why. There are exhibitions now going on in New York that claim to be removed from any kind of human involvement. In other words, the algorithm has taken over. Now, how I understand the algorithm is it has to deal with quantitative reasoning, okay? That if you introduce qualitative reasoning into the algorithm, it's not going to work. And I think I stated that in my my presentation. that the algorithm is really a quantitative form of measurement. And I do not believe that quantitative forms of measurement relate to either art or the criticism of art. I think that it exists more on a scientific level. Now, perhaps I have misunderstood something, but I think that what we have to maintain in terms of my field is the importance of qualitative reasoning in relation to what we're seeing and what we're thinking and what we're feeling in relation to art.
Thank you very much. I agree entirely.
Thank you.
Violeta.
Yeah, I'm so happy to see what happens when correspondences are possible. And I found also the this brainstorming around our so important theme so incredible. So anyway, I think we are all of us happy, and in fact, it's a beginning of a long story we have to follow. Thank you so much. And see you in 2 weeks.
In 2 weeks.
Okay.
Thanks for the organization. You do a great job.
Thank
you
you.
very much.
Yes,
your
I
participation.
appreciate the organization. I don't know what I would have done without the organization. I appreciate it so much.
Okay.
Bye-bye.
Okay.
Goodbye.
Bye-bye.
Nice to meet you all. I hope to see you, at one of our meetings
Yes,
somewhere down.
We hope so.
I shall call
All the
you.
best.
After Corona.
Yeah, right, exactly.
Okay. Goodbye.
Okay.
All the best. Thank you so much.
All the best.
Thank you.